Hello and welcome to this lesson on navigating and understanding the periodic table. In today's lesson, we will firstly ask, what is the periodic table? Learn how to navigate it and identify elements. Secondly, we will also explore how the periodic table is organized into groups and the significance of periodicity. Thirdly, we will aim to understand the significance of the periodic table in terms of identifying trends and organizing elements in a way that allows us to predict their properties and make discoveries. Developed by Dmitry Mendeleev in 1869, the periodic table has been instrumental in advancing our understanding of chemical reactions and the nature of matter. First and foremost, the periodic table is a systematic arrangement of elements. Each element is placed according to its atomic number, which is the number of protons in its nucleus. This arrangement by atomic number is fundamental because it reflects the principle that the properties of elements are largely determined by the number of protons in their nuclei. Beyond simply listing elements, the periodic table is an intricate pattern of rows and columns that reveal trends and relationships between different elements. There are just over 100 elements that make up everything in the universe. These elements are organized into periods, which are represented by the horizontal rows, and groups, which are represented by the vertical columns. One of the key features of the periodic table is the grouping of elements into columns, known as groups. The middle block of transition metals is not labeled with group numbers in your GCSE course because of their more complex electron configuration. You don't need to worry about this for now, but it is something you may go on to study if you do A-level chemistry. Elements within the same group share similar chemical properties. This similarity arises because they have the same number of electrons in their outermost shell, also known as valence electrons. For example, all the elements in group 1, also known as the alkali metals, have one valence electron, which they tend to lose easily, making them very reactive. This vertical arrangement of elements in groups allows us to easily identify elements that have comparable chemical behaviors. When you look at group 7, you will find that they all have 7 valence electrons and exhibit similar reactivity and chemical properties. Now, let's consider the term periodic in the periodic table. The word periodic means appearing or occurring at intervals. In the context of the periodic table, it signifies the recurring pattern of properties exhibited by elements as one moves across a row or period. Each period signifies the addition of a new electron shell. As you move from left to right across a period, the properties of elements gradually change in a predictable way. For example, within a single period, you might notice a progression from metals to metalloids to nonmetals. Periodicity occurs because as we move from left to right across a period, electrons are added one by one to the same energy level or shell. This sequential addition of electrons causes regular changes in atomic and chemical properties. For instance, atomic radius decreases across a period due to increase in positive charge in the nucleus, which pulls electrons closer. The periodic table also provides a framework for predicting the properties of elements that have yet to be discovered. For example, before the element germanium was discovered, chemist Dmitry Mendeleev predicted its existence and properties based on gaps in his periodic table. He called the yet-to-be-discovered element Eka silicon because it was one place below silicon in his table. The discovery of germanium in 1886 by Clemens Winkler and the subsequent confirmation of Mendeleev's predictions solidified the significance of the periodic table in chemistry. This shows that by observing patterns in the table, we can anticipate changes in physical and chemical properties. For example, atomic size increases across a period from right to left and increases down a group. This helps us predict how elements might interact chemically. So, the periodic table isn't just about summarizing known chemical behavior, it also progresses scientific knowledge. Continuous exploration and analysis of the periodic table allow us to refine our understanding of existing elements and discover new ones. This ever-evolving map of elements aids in the inventive process of creating new materials and substances with desired properties. Great work! That's everything for today. In today's lesson, we delved into how to navigate the periodic table to identify elements and understand its significance in organizing and predicting the properties of elements. We began by examining the structure of the periodic table, noting how elements are arranged in order of increasing atomic number. We then explored the organization of the periodic table. We looked at how elements with similar properties are grouped into columns known as groups. Each group contains elements that share chemical properties and react in similar ways. Additionally, we discussed the concept of periodicity, which refers to the recurring trends or patterns in properties that occur at regular intervals across the rows or periods of the periodic table. For instance, elements in the same period show a gradual change in properties. By examining these aspects, we highlighted how the periodic table not only organizes elements in a logical manner, but also allows chemists to predict the properties and behaviors of elements based on their position. We also highlighted the importance of the periodic table in predicting the behavior of elements and making scientific discoveries. By understanding periodic trends, scientists can anticipate the reactivity and properties of elements, which is crucial for developing new materials and compounds.